look at parallel lines. So the first thing we're going to talk about is that parallel lines have the same slope. And parallel lines have different y-intercepts. Okay, so if we're going to look at these, this is in y equals mx plus b slope-intercept form. Right here, that's my slope of my line, 1/3. When we're talking about parallel lines, they have to have the same slope. So we're going to write a slope-intercept form of an equation of the line that passes through -3, -5, and is parallel to y equals 1/3 x minus 8. So what I'm going to do is I'm going to put this in point slope form because I have a slope and a point, so it works for point slope form. So I'm going to use y minus y1 equals m times x minus x1. And I am going to put 1/3 in for the slope. So that's my m. -3 is my x1. -5 is my y1. So I'm going to go y minus a -5 equals the slope, 1/3, times x minus a -3. Make sure when you have two negatives that you make it a positive. So those are why these change. And then I'm going to get this in slope-intercept form. To do slope-intercept form, first I'm going to distribute, and then I'm going to get y all by itself on that side. So I'm going to distribute my 1/3, and I'm going to get y plus 5 equals 1/3 x plus 1. 1/3 times 3 is just 1. Now I'm going to get y by itself. I'm going to subtract this 5. Remember to only do it under the like terms. 1/3 has an x, so I'm not going to subtract it from there, just under that 1. So y equals 1/3 x minus 4. That is my line that is parallel to my original. They have the same slope, different y-intercept. All right, I am going to try two more. This one is again in slope-intercept form. So remember, my slope has to be the same if it's parallel. So my slope is going to be -2. Here is my point, -3, 3. That's going to be my x1, y1. Again, when I have a point and a slope, I like to use point slope form. So I'm going to say y minus y1, which is 3, equals m, which is -2, times x minus x1. Right here, I have got two negatives, so I'm going to change that into a positive. My next step is to distribute. I'm using these arrows to show distribution because I don't want to just times -2 by x, but by everything inside the parentheses. Y minus 3 equals -2x minus 6. Now I am going to add 3 to each side, making sure I do it under the ones that are the same. So y equals -2x minus 3 is my final answer. These two lines are parallel to each other. They have the same slope, different y-intercepts. We're going to look at one more. We are going to look at number 4. This is right in slope-intercept form of the equation that passes through the point -5, 4, and is parallel to 2x plus y equals -62. Do you know which form this is in? If you said standard, you are correct. It's in standard form. The slope is still right in front of x. I can change this very quickly to slope-intercept form by subtracting 2x from both sides, so I get y all by itself. And I get y equals -2x minus 62. Right here, That slope is all by itself now. It's in slope-intercept form. So I want my m to be -2. My point is -5, 4. Again, I can use x1, y1. I'm going to put it in point slope form. I'm going to write down the formula one more time. I didn't on that last one. If it helps, write it down. So I've got y minus 4 equals the slope, m, -2, times x minus a -5. Two negatives do make a positive. Step 1, I'm going to distribute my -2. So I get y minus 4 equals -2x minus 10. I add 4 to both sides, and I'm left with y equals -2x minus 6. This right here in slope-intercept form is parallel to this equation up here that's in standard form. They will never intersect. They will be right next to each other. And that is it for parallel lines.